Hello everyone, welcome back to CFD College. I'm Ashkan and in this video I'm going to talk about how we can generate the mesh, the grid based on Y plus in ANSYS Meshing. So in many projects, actually in most of them or all of them, I think, I mean the turbulent flows, we need to think about Y plus, the turbulence model, wall function, or and y plus. So we basically need to generate this mesh, the grid, based on the y plus that we want. I know we can generate a mesh, do the simulation, and then check the y plus, and then modify the mesh based on the results. But I think it's a bit time consuming. I think there are some ways that we can find the grid size we need, especially on the wall in both internal and external domains, flows, and we can generate the first mesh based on that size. And after that, we can modify the mesh if the y plus isn't uh, in the range that we want. But it's good to generate the first mesh based on the y plus that we want. So in this video, I'm going to teach you how to do that in external flow using two Excel files and in ANSYS Meshing. So before starting the video, if you like these kinds of videos, I mean CFD, ANSYS Fluent, generating the mesh, post-processing, please subscribe this channel. I have lots of useful videos in this channel for you, and you can enjoy them. Uh, so please subscribe, give us a thumbs up, and hit the notification bell, and do not forget to introduce us and share these videos with your friends. Okay, let's jump to the workbench. Uh, Let me create a fluid flow fluent block system. I go to design modeler. In this tutorial, uh, I will show you how you can generate a mesh based on Y plus in ANSYS Fluent, in ANSYS Meshing. In external fluid flows, for example, imagine that we have flow over a plate. You can do it in any external flow you have, for example, flow over airfoil or a blunt body or something. Uh, so let me, for example, create a sketch and a rectangle which represents the flow over a flat plate. On the bottom we have the plate, and here is the inlet, the outlet, and the far field flow. So we will do we will generate the grid in both structure with both a structured one and unstructured one. So for example, if the length of the uh, plate is 20 meters and the height of the domain, for example, is 5 meters. Okay, 15 meters and 5 meters. Then I generate and create the 2D domain. The thing that I wanted to say, you can apply them on 3D and 2D, doesn't matter. So now let's go to ANSYS Meshing first. I will do it in unstructured mesh. and then I will show you how you can control the first layer thickness in structured mesh. And I think in a structured mesh is a bit complicated, but in unstructured mesh, it's easy. You can use inflation. So first, we need to find the you know, first layer size. So we consider a Reynolds number. Uh, then you need to go to you know, go on different websites, Y plus calculator websites, and I use this Excel file that I generated. It's super easy. It's not something difficult, and you can find the link of these Excel files in the description below. Uh, so first of all, we need to find the first layer thickness based on our Reynolds number. So if you have your Reynolds number, you can use the top table. If you don't have it and you would like to use, you know, density, viscosity, velocity, the length scale, and let Excel calculate the Reynolds number, you can use the second table. So in the first one, I assume that I want my y plus to be 1. The L in this particular uh, flow would be the length of the uh, you know, plate, which is 50 meters. And let's say the Reynolds number is 1 million. As I mentioned, you can go with the second table. The length is also 50 here, and this is the viscosity of the air, density of the air, and the velocity. So I will go with the first one because I assume that the Reynolds number is 1 million. The length is the length of the plate, you know, if at the end of the plate we have y plus near 1, uh, we will show that in the you know, regions near the inlet, y plus is definitely below 1. So using this table, and know something, this table and any other y plus calculator on the net, they are not 100% you know, precise, because the relationships and formulas behind these calculations have been made by, you know, many assumptions. So these can give us, you know, the first value, which is good and precise, but not 100%. So using this table, I can understand that if I have a plate with a length of 50 meters, if you have an airfoil, the length scale would be the chord length of the airfoil, for example. And the Reynolds number is 1 million. And if I want y plus to be below 1, I need a grid with the first layer thickness of 1.15 millimeters. So if I want to generate that kind of grid, and first, as I mentioned, we will go with unstructured grid. We need to use inflation. So if you want to generate an unstructured grid, you should right click on the mesh and add inflation. This is the geometry. This is the boundary I want to generate boundary layer on. And you should change the inflation option to first layer thickness, and it is 1.15 millimeters. So the number of layers, for example, 12 or 15, whatever you want. And this is the growth rate. 1.2 is it's not bad. It's good for most of the projects. And so here we have inlet, here we have outlet. This is the plate. If I generate a mesh, you will see the boundary layer. I know you need to add some sizing or reduce the number of the element size, for example, to 0.5, or you can, as I mentioned, add some sizing, for example, on these edges. And for example, I want 20 nodes, 200 nodes on these lines. If I click on update, you will see the grid. We call this grid unstructured. And let's add a method and change the method to triangles. We need another sizing for inlet and outlet, for example, 50, and keep the behavior soft because we have a boundary layer here. We can also increase the number of layers to 25 to have a better mesh. See, this is the boundary layer on this plate, and using this grid, you will have y plus below 1 if the Reynolds number is 1 million. You can modify the mesh because it's not I think it's not good. You can decrease the number of elements to 0.22, for example, to have a better mesh. See, this is how you can generate a boundary layer, how you can generate the grid on the wall based on the y plus, and this is how you should do if you want an unstructured grid. But what if because the geometry is not complicated, it's simple. And what if you want to generate a structured grid? So let me duplicate this fluid flow here, and let's go to ANSYS Meshing. So now I want to show you how you should create a structured mesh. To generate a structured mesh, you don't need these options, inflation and triangle method, because when you use inflation, it means that you want to generate an unstructured mesh. So I will delete it. Instead, I add face meshing. See, this is a structured mesh, but how you can control the grid size on the wall. That's where the second Excel file comes in. In this Excel file, which is based on, bias factor and the edge length and the number of division, you can use this to generate a structured mesh in ANSYS Meshing, and to control the uh, grid size on any surface, on any boundary. So how it works? Sorry. You know that this line the height of the domain was 5 meters. So if I go there, the edge length is 5 meters. The edge length means this line, the line perpendicular to the surface, to the boundary you want to control the grid size on that. So the edge length is 5 meters. Then you have to uh, assume two values, number of division and the bias factor. So I have this edge sizing on these lines. I will change them to the behavior to hard, and I will apply a bias. So first I enter 50 to check the direction. As you can see, the direction for this line is reverse. Now it's okay. It's getting finer and finer towards the plate, and it should be the same for this line. Yeah, this is uh, okay. Now we have two parameters, number of divisions and bias factor. So from this Excel file, we knew that the first layer thickness should be 1.15 millimeters. Now you should change these values to get that. For example, I say that I want 50 cells in the vertical direction, and the bias factor, for example, is 100. If I choose 50 for number of division and use bias factor of 100, the first layer thickness would be 4.53 millimeters. But I want to be 1.15. So I have two ways, either increase the bias factor or increase the number of divisions, or both. So see this, if I double the number of division and bias factor, so I have 100 nodes, and with bias factor of 200, the first element length or height, it's better I think, height would be 1.3 millimeters. So if I increase it a bit, yeah, 235, 230. Okay, 235 is fine. Then we will have 1.15 millimeters for the first height. And here the growth rate is calculated, and you can see by these numbers, I mean the number of division and bias factor, the growth rate of the mesh would be 1.06, which is perfect. I think it's it's better than perfect, I think, because the perfect value for growth rate is 1.1. This is smaller than that. So the mesh would be fine. If you want to see the next element height, you can change it, and then you can see the value. So 100 elements with 235 for the bias factor, 100, 235. Let's see the grid. This is the grid that we have. As you can see near the plate, we have really fine cells which satisfy the y plus below 1 condition that we wanted. So if you don't want this type, you can play with these numbers. For example, you can increase the number of division, and then you can decrease the bias factor. That's okay. So you can change it 150 and 140. So again, using this grid, which is a structured grid, you can have a high quality mesh, and the condition for getting y plus near 1 is satisfied. I know that in unstructured mesh is easy, but I wanted to teach you how you can do it in structured mesh. Uh, you can do it. The procedure is the same in all the projects. Flow over an airfoil, over a bus, over an airplane, over a building. By this method, you can control the grid size to get the proper y plus, to get the y plus value that you want. So I think that's it. It's the end of this video. I hope you enjoyed it, and I hope this video is helpful for you. So if that's the case, please subscribe the channel, share this video with your friends, and introduce us to them. Thank you for watching this video, and until the next video, take care of yourselves and bye bye.